Hi guys, today we're going to go through the topic C5 chemical changes. We'll start by looking at the reactivity series. We're going to go over half equations and then just some rules that you're expected to know about how metals react. The reactivity series is a list of metals in order of reactivity. Now, as you go down the group, the metals become less reactive. A couple of other things you'll notice here is that we've got carbon and hydrogen. They're obviously not metals, but they are there for a reference point, and we'll come on to why carbon and hydrogen are there. Now, just a bit of recap. How do metals react? Well, we know from the ionic bonding topic that metals react by losing electrons. Okay, so that's the first point here. That you can make a note of is that metals react by losing electrons, and we know that they form positive ions as a result. Now, we call that oxidation. So we'd say that when metals react, they are oxidized, and we'll get on to what that means. It's actually got a couple of meanings, but very, very relevant to this topic. Now, when we're talking about the reactivity of metals, more reactive metals have a greater tendency to lose their outer shell electrons and form positive ions. So if we go back to the reactivity series, we can say that potassium has a greater tendency to lose electrons compared to, say, magnesium. Now, if we look at this example here of magnesium, we know from ionic bonding that magnesium, because it's in group 2, has 2 electrons in its outer shell, and when it reacts, it loses those 2 outer electrons, and as a result, it forms a positive ion. Now, if we wanted to illustrate that as an equation, we'd use something called a half equation. Now, a half equation essentially tells us what's happening to an atom when it's reacting. It tells us whether it's gaining or losing electrons. Now, we know from this simple example that when magnesium reacts, it loses 2 electrons from its outer shell, and as a result, it's gone from having no charge as an atom to having a 2+ charge. And simply we'll use this symbol E minus, E for electron, and this minus charge tells us the charge of an electron. We know that each electron has a relative charge of -1, and we've got a big 2 in front because each magnesium atom has lost 2 electrons. We can also say that because it's lost 2 electrons, that the magnesium atom is oxidized. Okay, now, like I said, oxidation has a couple of meanings. Another meaning for oxidation could also be that oxygen has been added. For example, this is a really common example here. Magnesium plus oxygen makes magnesium oxide, and we can say that the magnesium in this reaction was oxidized. Now, if we look at this dot and cross diagram, well, I'm just showing half of the equation. We know it's actually 2 magnesium atoms, and oxygen's a diatomic molecule, so there should be 2 oxygen atoms. But just for illustration's point, we can see that the magnesium loses 2 electrons from its outer shell, and each oxygen atom gains those 2 electrons. And we can see as a result that magnesium becomes a positive ion and oxygen becomes a negative ion. Now, we're going to go back to those half equations. We want to tell the story. We want to show what's happened using some equations. We want to know, where have the electrons gone? Have they been gained? Have they been lost? So we know from our previous example that magnesium, it loses electrons. In this case, from the balance equation, this total reaction, 4 electrons are lost. And oxygen, because it's a diatomic molecule, each oxygen atom would gain 2 electrons each. So in total, the half equation would be, with the addition of 4 electrons, we form 2 oxygen ions. Now, this is a really useful acronym for us to know that yes, we've got oxidation, but actually we've got another type of reaction happening here, which is called reduction. So if we use the acronym oil rig, oxidation is loss of electrons and reduction is gain of electrons. So if I look at my dot and cross diagram, it's very obvious for me to see which atom has lost electrons and which atom has gained electrons. It's quite a simple rule. Essentially, metals always lose electrons, so metals are always oxidized. Now in this case we can see that magnesium's been oxidized because it's lost 2 electrons from its outer shell, and each oxygen atom is reduced because each oxygen atom gained 2 electrons each. Now if we want a simple definition of a half equation, which is what we've got up here, half equations essentially show what happens to each reactant. They tell us if the reactant's been oxidized or if it's been reduced. Now when both oxidation and reduction happen in the same reaction, we call that reaction a redox reaction. You might want to take a note of this definition. Redox reactions have oxidation and reduction happening at the same time. So this, for example, would be a redox reaction. Right, there are a couple of rules. So remember I said that we need to know about the different reactions of metals, how metals react. These are just some general rules that you need to know off by heart, okay? So apology, I can't get it in the frame, but I'll just move the paper. So when metals react with oxygen, like we just saw, magnesium and oxygen, we form what we call a metal oxide. So previously we made magnesium oxide. Metals plus water make metal hydroxide plus hydrogen gas. So you might remember from the group 1 metals lesson, you might have done this reaction where by dropping small pieces of group 1 metals into water, we did form metal hydroxide, but you would have seen lots of vigorous bubbles being formed, and those bubbles were hydrogen gas. Metals, when they react with acid, form what we call a metal salt and hydrogen gas, okay? Now, I've underlined here acid and salt. Now, depending on the acid, you'd form a particular salt. For example, and again, you need to know these off by heart. So if you've got hydrochloric acid, HCl, in your reaction, the salt formed would be a chloride, okay? Now, it says metal salt, so if it was magnesium, plus hydrochloric acid, you'd form magnesium chloride. So you'd just give the name of the metal before the chloride. And it's really important, guys, that you remember the charges of these ions. So you need to know that in the acid, we've got chlorine ions. If you've got sulfuric acid, the formula, again, you're expected to know, is H2SO4. And the ion, of the formula of the salt is SO4 2-. So overall, this ion has a -2 charge. And we've lastly got nitric acid, HNO3. And the formula of the salt is NO3-. That has an overall charge of -1. Now, one thing you'll notice about all of our acids, one thing they all have in common is they all contain hydrogen, okay? And that's really important to when we move throughout this topic, because you actually are expected to know what happens when these acids react with metals, what happens to the hydrogen. Okay, now some other rules, so just some general rules that you're expected to know. Acid plus metal oxide. So say, for example, we took this metal oxide and then reacted it with some acid. What would we form? All right, we'd form salt and water. Salt and water. If we reacted acids with a metal hydroxide, we'd also form salt plus water. Acid plus metal carbonate. We'll get onto the formula of hydroxides and carbonates in a minute. We'd also form a salt, water and carbon dioxide. Okay, now on this table here, I've just summarized for you the formula of ions that you're expected to know. So we've got here the formula. We know that if a metal is in group 1, the formula of the ion is +1. If it's group 2, the formula of the ion would be +2. Transition metals, this one's more for the separates. We don't really learn or go into too much detail in combined science, but generally transition metals are quite unique because their charges can vary when they react. So usually we use kind of Roman numerals to indicate the charge of the ion. So we've got copper and 2 in brackets, so we know that the ion would be 2+, and iron 3 in brackets would be a 3+ charge. Okay, when we do some examples together, that would be really, really important when you're writing out the formula of some of these products. Right, negative ions that you need to know. Well, oxygen, obviously, because it's in group 6, it gains 2 electrons, it forms an O2-. Hydroxides have a single charge, a -1 charge. A hydroxide ion is oxygen, hydrogen. Carbonates have an overall charge of -2. We've got 1 carbon atom bonded to 3 oxygens. Chloride, simple, group 7, gains 1 electron, so Cl-. And the overall charge of sulfate and nitrate, again, we've talked about these earlier, but it's quite nice to get it all on one table. So guys, remember, you are expected to know these off by heart. Okay, and I'm going to give you a chance to write out the formula of some compounds using these charges. Okay, so the next thing, which is a bit of a recap because it did come up when we did ionic bonding, we need to know how to write out the chemical formula of different compounds. We've got lithium bromide. So this is quite a nice little checkpoint for you to use when you're writing out formula. Firstly, if we've got a compound and we know that this is an ionic compound because you've got a metal and a non-metal, first thing you need to do is work out the charge of the individual atoms. So we've got lithium's obviously in group 1, it has a +1 charge, and bromine's in group 7, the ions formed have a -1 charge. Now, when the compound is formed, it's really important that those charges add up to 0. And in this case, they do. This has an overall charge of +1, this has an overall charge of -1. So overall, the charges do add up to 0. So it's quite simple. When I'm writing my formula, the ratio of each ion would just be 1:1 because the charges add up to 0. So it's quite simple. The formula would be lithium bromide. Let's do another example together. Okay, so iron to bromide. So straight away, I know if I've got these brackets here that the charge of my iron is going to be +2, and bromine will always be Br-. Now, do these charges add up to 0? This has an overall charge of +2, this has an overall charge of -1. +2 minus 1 does not equal 0. So I know I need to do some adjustment here. If this has an overall charge of +2, what I can then do is I can realise actually I need another bromide ion. So actually, if I change my ratio from 1 to 2, let's see if that makes a difference. Right, so if I've got 2 bromide ions, well, +2 minus 2 gives me 0. So sometimes when you're writing out the formula, you need to check that the charges add up to 0 and you need to make the appropriate adjustment. And as a result, my formula would be FeBr2, because for every 1 ion, I need 2 bromide ions. Right, let's do another example, a little bit more challenging. We've got magnesium nitrate. Right, magnesium, forms Mg2+, so it has an overall charge of +2. And nitrate, remember that was one of the formulas that you need to know off by heart. Overall only has a charge of -1. So we know here our charges do not add up to 0. I'm going to need another nitrate. So if I change my ratio from for every 1 magnesium, I need 2 nitrates. So remember, the whole thing has a charge of -1. So I need 2 of those in order to make my charges add up to 0. The formula will therefore be MgNO3 2 in brackets. Remember, guys, we use brackets when we have kind of a formula with more than one element. So this 2 means there's 2 lots of everything in the bracket, and we know that we needed 2 lots of nitrates for every 1 magnesium ion. Right, what I've got for you guys is some examples to try. I'm going to try and cover these answers. Yeah, so what I'd like you to do, we'll just cover this up. If you just pause and use that same structure or that same layout, work out the ions, the charge of the ions. Do the charges add up to 0? Do you need to amend the ratio of each ion? And then write out the formula. So if you just pause it now and have a go, maybe give yourself about 10 minutes to try, and I'll show you the answers now. So